today, the topic will be about Git and about version control systems in general. I have the slides already put online because in the slides I present, there are no reference slides. So I will not list all the commands that are available with Git. If you know Git, there are a lot of different options and things you can do. And those reference slides are included in the slide set that you can download at this URL. So they're down in the list. There is, for today's date, you can already download the slides. Some other remark is not, it's only important for the reference slides. Starting with version 2.23, Git really consolidated and cleaned up their interface. And some commands are only valid for Git newer than 2.23, and 2.23 is quite recent. Just to give you an idea, on CS-HPC, the standard Git that's in the path is 1.17, and on EMI, it's, I think, 2.2 or something. So just that you are aware of that. Okay, so let's start. So the first question that arises is, well, what is this good for? Why do I need a version control system? And well, the reason is that software development is inherently hard. Yeah? So you have to keep control about a lot of things, and it's messy for a lot of people. They experience this as a very insecure and hazardous undertaking. And one aspect of software engineering, that's the art or the craft to write software in a professional way, is software configuration management. And software configuration management, again, consists of several different things. And one of them is what is called, I have this from Wikipedia, of course, identification, control status, and auditing of configuration. And this is the topic of today. So version control systems. Of course, there are a lot of other aspects. Maybe we talk about this in another HPC Cafe talk. And today will be about version control systems. So what are the benefits? So why should you do that? And again, this is a list. I will break this down. So first is change management. You want to know who changed what when. This is especially important if several people collaborate or develop together on a single software project, or when the development team is spread out, not at a single place. Then you want to archive old states. You want to have access to all previous versions and want to be able to look at previous versions. This is especially important for tracking. If something went wrong, you want to be able to track where this came from and what did you change when. Then reconstruction of previous file states. If you mess something up, you want to be able to go back to an old safe and state with some guaranteed properties. Next, coordination of access of multiple persons. When a lot of people develop on the same project, you need some kind of synchronization and management of changes. Simultaneous development of variants, also called branching. So you want to simultaneously develop or follow different tracks on a software project. And finally, manage baselines. So you want to be able to mark relevant states with some meaningful name, so that you can list it, and it's easy then to find guaranteed baselines easily. You could break down those different benefits into three groups, and this is documentation, backup, and synchronization. So that's are the main three benefits of using a version control system. And you don't need necessarily to use all three of them. So for example, I'll be honest with you, for private projects, I use Git mostly for synchronization, and maybe for backup. Because the reason is backup and synchronization, you get more or less for free. Documentation, for this to be really useful, you have to be more disciplined and put a bit more effort into it so that it really works out. And we will talk about this also later on. So some history. If you know me, you know that I'm always interested in where things do come from. So source code control systems are around since the early 70s. And I think there even was something earlier, but in the early 70s, there was something called SCCS, Source Code Control System, and this is actually a POSIX standard. So very early, there was the demand for controlling changes in software. And 10 years later, maybe the older of you still know this, a system called Revision Control System, RCS, was created, and was actually created by a German computer scientist, Walter Tichy. He's still a professor at KIT, Karlsruhe. And this was, he wanted to create and fix or create an improved version for this SCCS system, which is, by the way, also still around. Yeah. The next development was then in 1986, and there the so-called concurrent versioning system, CVS, was created. And the previous systems were local only, so you had local revision control, but no way to exchange information. And CVS was the first revision control system where you had a centralized client-server model. Under the hood, this still built on RCS, so you could see this as a front end to RCS with a client-server support. In 2000, CVS had some weaknesses. An improved version of the CVS model was created called Subversion. So when I did my PhD, Subversion was the modern thing, yeah, to do. And the old guys, they used CVS. In 2005, then there was a new trend, or in the mid, several of those things, it was a new trend to use so-called distributed revision control system. And the demand was because for very large open source project with a lot of developers that are distributed around the globe, centralized client-server models just do not work well. It doesn't scale to hundreds, thousands of developers. And there was the demand for something distributed, asynchronous. And by the way, at this time, roughly at the same year, 3 different systems came up. There are more, of course, also commercial systems. These are just some open source systems. Is Mercurial, HG in 2005. Then Git, which was created by Linus Torvalds, also in 2005 as a replacement for BitKeeper. And then finally, I also want to mention Fossil. That's an alternative created by Richard Hipp, and it's the SQLite creator. Mercurial, in the beginning, was a real contender to Git, so both were roughly same popularity. Nowadays, Mercurial is not that widely used anymore. The only major user I know is Facebook. So as far as I know, Facebook internally, everything is done with Mercurial. Just very short, those 2 different models, just to give you an idea, centralized versus distributed version control system. Centralized is clear. Everything, the whole history, everything is on a central server, and you only have your working copy, so your sandbox on your computer. This means anytime you want to submit changes, you have to have contact to the server. So everything is serialized through the server. In a distributed version control system, you could also have a server-like model, so it's easy to mimic this client-server model, but essentially the whole repository is duplicated on every computer. So everyone who has a sandbox or works on this project has the full repository. And this allows that he can has or push forward his own history without connection to the outside world, without network. And then, of course, that's the downside. From time to time, he has to explicitly sync, for example, with a server or with other developers which work on the same project. So now some basic facts about Git. Git means, I need to look at this up, unpleasant person in British English slang. If you know Linus Torvalds, maybe he's an unpleasant person, I don't know. And this is the de facto standard distributed version control system. So nowadays, Git is really the if you talk about version control systems, you talk about Git, mainly. The development, as mentioned, began in 2005. And Linus Torvalds wanted to create a replacement for the proprietary BitKeeper software they used at the time for the Linux kernel development. Soon the maintenance was taken over by Junio Hamano, so Linus Torvalds really only put down the first initial implementation, and since then Junio Hamano does all the work. It's implemented as a set of command line tools, and it was designed obviously for the Linux kernel developments. And this Linux kernel development has some specific requirements. It needed to be scalable, and Linus Torvalds wanted something where branching is very simple and where merging is very simple. So he could integrate all those changes and easily review all those changes for a very large developer community. So it has sophisticated branching support. It's very generic and flexible, so you can really implement any workflow you can think of with Git. It puts great emphasis on data integrity, so everything is checksummed, and it has a staging area. We will talk about that in more detail. This is a very unique feature of Git, that it uses a so-called staging area for reviewing your changes before you commit them. The website is listed here. Have a look at there. There is good documentation there. Also on the last side, they also have there a book online, which is really recommended if you want to get some information and learn about Git. So now it's the standard. That doesn't mean that's the best solution. The problem with Git is they improved on that, but it's still a problem. There is a downside that it's so flexible and so powerful, and that is that for 80% of the people only need a very simple workflow to get those three benefits we want to achieve, documentation, backup, and synchronization. And in Git, especially when you change from another version control system, adds really some overhead, which you might think is probably not necessary for your workflow, especially if you develop, for example, just on your own. Still, they improved on that, and they really also further improved the interface. So I think it already got a lot better to get the interface more, a cleaner, better interface, for the average user. Let's put it that way, so that you don't need to think about all those nifty details, because I, as a developer, I don't care about the sophisticated stuff. I want, for my simple workflow, I want to get those benefits without any effort, without any work I need to put into this. I don't want to struggle with remembering commands and so on. And that's somewhat the downside. Some terminology, not all of this is specific to Git, but some of those are specific to Git. It's a bit boring, but we need to do this because just to be on the same page about what the terms mean. So some very basic terms. Repository is where files, current, and historical data are stored. And remember, every worker who works on a project has a local repository. So there is nothing like a central repository. You might think that when you use GitHub, but you have the full repository locally at your computer. Then clone or fork, that's synonymous. You could also say copy. So cloning or forking is to create a repository containing the revisions from another repository. So you just copy the repository with all the information. A working copy is the local copy of files from a repository at a specific time or revision. And all the changes you do, so all the work you do on files in a repository are done on a working copy. In other revision control systems, this is also called sandbox. To check out is, well, the activity to create a local working copy from the repository. Now, synchronization. In Git, this is called pull and push. So this is about copy revisions or all informations from one repository into another. And pull is initiated by the receiving repository, while push is initiated by the source. Pull request, this is a term which you commonly see, for example, on GitHub or GitLab. And this is actually a developer which pushed some changes to a software project, and he asks someone else, hey, I have some changes here, please pull them and merge them into the, for example, main repository where the releases are done. Yeah? Then a conflict occurs when different parties make changes to the same document and the system is unable to reconcile the changes, and you have to put there automatically. And this is something people often fear a lot, especially beginners. So they think that when a conflict occurs, something went wrong or they made a mistake. That's actually not true. To have a conflict is really something common. It's part of the workflow. It happens. Yeah? With a distributed version control system, you cannot, in general, prevent conflicts, especially if you have a lot of developers. And the problem with a conflict is you really must resolve this by hand. So usually, or in many cases, it can be automatically fixed. But when there is a real conflict, a user must by hand then decide if the changes are combined or if you want to select one change in favor of the other. We will also talk about this in more detail. And then when you fix a conflict, then this act of user intervention to address it is called to resolve the conflict. Branches and commit. A branch is a set of files under version control, or a set of files under version control may be branched at a point in time. And from that time, 2 copies of those files may develop at different speeds or different ways independently. So every branch then has its own version history, you could say. A commit is a modification that is applied to the repository, and well, to commit is the act and write or merge changes made in the working copy then back to the repository. Finally, revisions and text labels. This is something I will not talk about here in this presentation. I have one slide in the slide set about doing tags. You could say that this is an advanced topic. So revision is a state at a point in time of the entire tree. This was a main feature of Subversion versus CVS. In CVS, the version history was really only applicable to single files, and it was easy to really get an inconsistent state for the overall repository. Since Subversion, the standard is that you have so-called atomic commits. So this means that a revision is always valid for all of the repository, so for the entire tree. Then a tag or label is a snapshot in time, and you give then this snapshot a user-friendly, meaningful name. So you could say it's just a label which points to a certain revision. Trunk or master, this is the unique line of development that is not a branch. So the root branch where all other branches branch from, you could say. In Git is called master, but this is really not a strict rule. It's only a convention that it's called master. Still, everybody calls it master. And head is the most recent commit. This is also, you could say, a special label, is the most recent commit either to the trunk or to a branch. Okay, so now we have this out of the way, and I want to show you today for this talk is more targeted to beginners or smaller projects, I would call. I want to only introduce to you one very common workflow. And that's also the workflow, for example, I usually have. And this is a centralized workflow with different clients. So a classical client-server workflow. So in most cases nowadays, you use Git with some software as a service platform, or you may have a Gitolite. I have some information on that. That's a Git server you can easily deploy yourself. And where the repository is stored, and all the workers will sync with this central instance, so with this servers. This workflow applies for one or more person, so it really makes no difference if you're alone or if there are multiple persons. So now in my example, for example, I have a laptop and I have a workstation, and maybe I have another copy of my project, which is on the HPC cluster. Well, and this applies on per repository, yeah, of course. So now the first thing you want to do is you want to get the software project to your different computers where you want to work on your project. And this is called to clone a repository. So you get a copy of the repository on each of those computers. Then you start working on it, and start working on it in a version control scheme means you apply changes. You do changes, you add files, and those changes add revisions. Revisions are well-defined states, snapshots in the Git speak. And let's say you start working on the laptop and create 2 different revisions. Now, of course, those 2 revisions, because all other instances of the repository have their own revision timeline, are only on your laptop. So if you're alone, usually, and you are disciplined, you can really do this in a way that no issue, no conflict happens by syncing the state always with the central repository, so with the central server, before you start working on another machine. So what you do now is, you push the changes to the server. Now those revisions are also available on the server. And next, maybe you want to go on to work on your project on the workstation. And the first thing before you start is you pull those changes from the server. Now you have the same state on the workstation where you left off on the laptop. You go on with work, add additional revisions, and push again those revisions to the server. Now you want to go on the laptop and again pull and so on. So if you do this in such a synchronous way, and this works especially if you're alone and, well, if you're a bit disciplined, then nothing bad can happen. If you really do it like that, for example, no conflict will happen because we'll only apply changes with a state that is in sync with all the other computers. So now we're talking about when problems happen. And what I already mentioned, it's not actually a problem. Yeah? So it's part of the deal to have a distributed version control system. So let's say on the HPC cluster, and let's assume that's another person. Yeah? And he also does changes to the project. He doesn't know probably that others did the changes. And I will talk about this later. Good practice, of course, is to always keep in sync, because the less you sync, the more probability is that you will have conflicts. Yeah? And he does 2 changes which he commits to his version of the software project. And someone later, he also wants to publish those changes to his co-workers, and he wants to push those changes. And what happens then is that the server will reject this push. And the reason is, or the message is that, well, there are changes on the server which you do not have locally, and you need to first pull those changes and merge probably this different state into your local version. And there's the good thing about Git. When you have something like that like a rejected push, it will also give you a notice you will see in the demo about how to fix it. Yeah? And how to fix it is, well, we want to pull now the state from the server. Now when we pull, actually a pull is just a shortcut to fetching data from the source, from the so-called remote. And the fetch only gets all the information you do not yet have locally, and then to merge the changes in your working copy. So in the branch you actually currently work on in the working copy, and the pull is just a shortcut to this fetch plus merge. And now two things can happen. And this only is a problem, or a problem can only occur if you applied changes on the same file, so on one document. Git has a very sophisticated algorithm for automatically merging those different changes. And in general, you can say, well, if changes are on different lines in a text file, for example, then usually things can be automatically merged. If you have a change, or if the things are more complicated and you have a change in the same area of the file or the same line, then a conflict occurs. And Git then will notify you that this file couldn't be automatically merged, and that you have a unmerged file which requires manual intervention. This means you by hand now have to resolve this conflict. By this, you create an additional revision which, well, does the merge, and then you push back this resolved conflict to the server, and you are fine again. Yeah, so that's the basic workflow and what can happen. As I already said, to have the conflict is nothing bad. Yeah? So this happens, yeah? and it's easily fixable. Yeah? There are some hints which makes life easier, but you shouldn't be afraid of a conflict. So now some words on file states, yeah, because this is a bit more complicated in Git, and there are certain terms you need to learn. Yeah. So files in general can be tracked. Those are files that were part of the last snapshot revision, or untracked. Those are all other files. And the tracked files, so the files that are part of the repository or are tracked in the repository, can have three different states in Git. Modified, that's a file that was changed but not committed to the database yet. So if you have a file that is under revision control and you edit it, then this file is modified. Then you have staged, and this is something special. A staged file is a modified file that is marked to go into the next commit. And what does it mean? In other revision control systems, modified files, when you do a commit, are automatically included. In Git, this is not the case. You have to explicitly add modified files to the so-called staging area. You have to stage them to make them part of the next commit. This appears inconvenient for a lot of people, but I hope that I can convince you that this is actually a good thing. It creates some overhead, but I talked about this purpose of documentation, and to have a good documentation of the changes and a good history, it requires some effort and some care, and this staging area helps you in getting a good documentation of your changes. And finally, there is committed, or you could call it unmodified. So this is all this files and data that is safely stored in the local database. And the standard workflow is, well, you modify files in your working tree. This might also involve adding new files. Then the file, when you add an untracked file, of course, that is staged then. Yeah, so that directly goes in the staged area. For the edited files, you need to stage first the file to get it in the staging area. And this, I will show you in the demo, this is not on a file granularity, but really on a change set, so on a change granularity. So also part of a file can be in the next commit. And you, for example, let's say you do by accident, it happens all the time with me because I'm not very disciplined, different changes in a file that do not logically belong to the same task, and so should not end up in the same commit. And because of the staging area, now you can really select one change, commit it, and then select the next change and commit it. So you really can separate changes. Even if you already did it to the file, you can separate them for the commit. And finally, then you commit. And this, well, saves all files that are in the staging area and stores the snapshot to the Git repository. So some general, wait a moment. Yeah, so now I want to start, at this point I want to start with the demo, and I hope this works out. I have a rough script for this, but as always, let's see if this works. So I created a clone or a fork of the bandwidth benchmark, and I want to demonstrate just the basic steps on this example. So here you see I'm using GitHub. That's the most popular, probably, software as a service Git provider. And here you have the option for any project to clone it. And you copy the URL, and then you get to your terminal. And here I mimic the setting. I have a laptop, RZE, and one else, and just start on the laptop. And we do a git clone and go on this URL. And there we are. And by default, you get the directory is named like the repository. So let's change to that. You can also get it another name by specifying another name behind the URL. Now, the first thing we want to do is we want to add a file. So let's see what's in there. This is a C project. Let's go to source and just copy some improved. Now, when you view a git status, that's the standard way to see in which state the different files are. You see that there are untracked files. Yeah, so he only will show you here untracked files or tracked files that are not unmodified. And you see some improved is untracked file. And as you see, he already suggests to you what you need to do next. So use git add to include in what will be committed. Yeah. So before we do that, we want to edit another file. So maybe we change something. Yeah, let's change, I don't know, maybe copy. By the way, can you read it? Is it big enough? I hope so. And well, as you can see here, I have some variables that are not used. So well, just remove them and save it. And now do git status again. And as you can see now we have the untracked file, the file we added, and we have here a modified file. So this is a file that is tracked, that was part of the last revision, but we changed it. Yeah, we edited it. And here we see changes not staged for commit. And again, Git suggests to us what we can do with it. Yeah, so we can git add to add it to the next commit, or we could git restore. And now this is something, git restore is already this new command. Yeah, so my git is, I think, 2.24. On your machine, this command may not be available yet. Yeah, so please then look it up. In the reference slides, I also have the old command included. Yeah. And well, let's do something additional. Yeah, let's delete a file. And for deletion, there is the git rm. And which file do we make? Yeah, let's delete the license file. Okay, do git status again. And changes to be committed. Now, for the first time, we have changes to be committed. So as you have seen, this RM actually, now when we look at the file, this file was really deleted. So behind the scenes, he deleted this license file, and he also added this change immediately. So this is already now staged for the next commit. And finally, we want to rename a file. Yeah? So let's have a look. I don't know. Let's rename move readme.md to readme. Again, let's look at the status. And the same thing. What happened behind the scenes is he moved the file, then he added the new file, and he deleted the old file, and he added those changes to the next commit. Yeah, so all those things were done behind the scenes. Thomas said that maybe with an older Git, it's not the deleted file is not automatically added. I'm not sure. Yeah, so you have to be careful. Good advice is always look at the status. Yeah, so to see what effect the command had. So I'm not sure. Maybe an older version of Git does not automatically add the old file to the next commit set. Okay, now also we want to add the other changes we did, or maybe maybe now we think, well, this can be said, let's put this in one commit, and if you want to commit then the changes, do git commit, and there is now, if you don't specify anything, it will fire up your editor, either with the editor that's specified in the environment variable editor, or there is a Git configuration option where you also can set an editor. How to do that? This is also in the slide set in the reference slides. For here, there is an option, a command line option, where you can specify the commit message on the command line. So rework, I don't know, license file. I know this is now bad. I always say, I told you do good commit messages, but I'm not good at this. And now let's try if this works. Okay, rework license creates a new revision. 2 files changed, 21 deletions. Yeah, that's it. Do a git status. And there we are. Yeah, so now the stage files are gone, and we have still those 2 sitting there in our repository. So the modified file here was not automatically added to this commit. So now what we can do is, or what we want to do is at this point, is to look at the history. And there are 2 options. There is git log, which shows you the full history. This is a bit, well, lengthy. Often it's useful, and I'm sorry, I have to look it up, because honestly, I don't use Git that much on the command line. I mostly use it from within my editor. There is an option where you get just 1 line history, and this is usually really useful for here we are, for a compact placement, especially if you do other stuff. Maybe you're searching for a certain revision, and there it's good to have just a more compact representation. And this is git log, and then option pretty 1 line. And if you do that, you get the checksum and the special markers like head points on the master, original master. That's the state, or the last known state, I have to say. So the state when we did the last fetch or pull on the remote. And we have the commit messages. And here, very important, those commit messages consist of a header, which is a short summary, and a message body. And here only the header is shown, and you already see that this should be short. So it's good. Don't make this too lengthy. Yeah? So it should fit in a line easily here in such a representation. When you want to reference a specific commit, it's enough to use just some some digits of the checksum. Yeah, this is usually sufficient. You don't need the whole checksum all the time. Okay, finally, let's say you want to commit something and you want to skip this staging area because you know there's only one file and you would just want to quickly get it off the table. Then there is a shortcut. You could do commit and then -am. And now this A option will automatically add all modified files to the next commit. So this means this change here, which we didn't stage up to now, will be committed when using this option. Yeah. Let's remove obsolete variables. Don't wonder, I don't see what I type because there is this, I can hide it, that's good. Okay, oops. Variables, obsolete variables. Okay, let's try this. Okay, status again. There we are. So you have seen, of course, the untracked files are not automatically added, yeah, because you don't know if they are not under revision control. So this A option will only add the modified files. To add this file, you have to add it explicitly. So git add source sum improved. So it's a new file. Now it's tracked. And if you git status, it's now in the staging area. So changes to be committed. And so we do a commit add new sum implementation or whatever. Okay, there we are. Now we have again a clean state. Okay, now we did a bunch of changes, and probably when we look now on the log, we see that we are now 3 revisions ahead of the origin master. So the master is 3 revisions behind, and so we will decide, okay, well, maybe that's a good idea now to publish our changes to the central repository. And so we do a push. There we are. Now when we do the log, our origin master is in sync with our state. Okay, now let's change to the other repository. And let's also clone this first. I didn't clone it previously. Now let's call this bv bench rrze. And now to make this useful, we do another change here. Let's change here. You see, yeah, let's remove those instrumentation and do a git commit rm. Oh, sorry. Oh my god. Yeah. So there you see, those are the bad examples for good commit messages, because it's meaningless. Yeah, it's in the same category. What I really like is minor changes or yeah, more fixes. Yeah, something like that. Yeah, that's very generic. Will always apply. This you use when you only use Git for synchronization and backup, because documentation is not functional, yeah, if you do it like that. Okay, so let's commit the stuff, push it again. We changed, try it, so let's remember that. And now we are in the other copy. And let's also add try it here. So you already recognize we want to do ugly things here. And let's do a D here. It's not valid C anymore, but who cares? And we also commit this change. Yeah. Rework is also a good one. And now I want to push my changes. Yeah? I don't know of the other changes. I want to push my changes. And when I do that, I will get this rejected commit. So Git informs me, well, failed to push. Updates were rejected because the remote contains work that you do not have locally. So you see, well, those hints are pretty useful. And well, he also suggests you may want to first integrate the remote changes with git pull. So let's do that. And there we are. The world ends. We have the mess. Yeah? Auto merging, try it. So Git first recognizes, well, try it was changed in the source branch. So on branch origin master. And it was changed on local master. He tries to auto merge, but we were bad. We changed the same line. And so auto merge fails and we have a conflict. And now when we look at on the status of the repository, we have so-called unmerged paths. So both modified source try it. And what we need to do now is we need to resolve this conflict. And what Git does is it will use markers, you will see in a moment, in the code that indicate to you where the merge conflicts happened. So let's do that. Actually, you will see later, you never will do that by hand, or at least I wouldn't recommend to do this by hand. This is now feasible here because it's easy, but as soon as it gets more complicated with a lot more changes, that's really very error prone, yeah, to do it by hand. You need a merge tool for that. Yeah? And I will show you later how this could look like. Well, so here you see down here, that's the revision from the server, and that's our current head. And well, now you have to decide what to do. Yeah, and well, what we want to do, because here this change is already included. Okay, let's clean up. Now you might be tempted to also remove that, but you shouldn't mix different things in the same commit. Yeah, so maybe then save this for later. So don't put things in the same commit that don't belong there. So let's clean this up, remove all markers, save this stuff, do a git status again. And we still have unmerged paths. Well, what we need to do, of course, Git doesn't know if we are now finished with merging. So we have to add this file to tell Git, look, I resolved those things. Yeah. Changes to be committed, modified. So now when you lie about that, yeah, when you didn't resolve the changes, well, then you really messed up your repository, and your files probably won't compile. And yeah, you need to really be sure about this and don't lie about that. Okay, now finally, let's commit it. Merge. I don't know. Just merge. That's it. Let's look at our log again. Here we are. Rework, merge, perfect. And we do a git push again. And now we can do the push and save back this state to the repository. So this is the basic workflow when you have a conflict. And if you have seen, it's not that bad, so it's feasible. So now finally, I want to show you one more thing. And This is there are a lot of options to undo things. So you want to undo things if you make a mistake. So examples for that is you want to unstage a staged file, yeah, because it doesn't belong there, or you want to revert a commit maybe, or quite often you want to add something to the last commit or re-edit the last commit message. Now, I'm honest, I never used this before, because as I said, I mainly use it for, and this is bad, don't do it, for synchronization. And there, when I forgot something to commit, I just commit it again, with the same commit message. But this is not good practice. And so we do it better now. Let's have an example for that. So let's edit the flags, the make flags. And let's edit a verbose there. And when we do the status modified, so let's add this. Oh, wow. We are brave. We just committed right away with our magic AM option. Add compile flag. But now we remember, oh, we forgot something, because maybe we just committed and then I wanted to add I wanted to add also this verbose flag to the other compilers, and this should belong to the same commit. And now what you can do is you just do this. So for example, let also add this for Clang. Wherever here, do a verbose, add this, change. Yes. Now we have this modified file. And now what we can do is we can, with all those things which are currently in the staging area, we can put this on top of the last commit and re-edit the commit message. And by that, just replace the previous commit. And the option to do that is called amend. I hope this is right. I think so. And we add a new commit message, like add flag to all compilers. And as you can see now, we have now two files changed. So he created this new snapshot with the additional file, and he changed the commit message. And when we now look at the log, you see that the previous commit is gone. It's not existing anymore. We have rewritten this commit with those additional changes. So this is quite useful. Okay, so that was it for this part. And now, last not least, I want to show you and want to motivate you that it's not actually a good idea to do this stuff from the command line, and that it's much better to do it from within an editor. And I use Vim, but such integration, and you also can use GUIs. There are GUIs available for all operating systems, good ones for Windows and Mac. And so I use Vim with the Fugitive plugin, and just to give you an idea why this is handy to use such an integrated thing. So I have here an untracked file and an unstaged file, and I always see that here. And let's edit an additional file. I think we changed copyright, if I remember correctly. And I want to show you something else. When you're not disciplined like me, you open a file and then you see stuff and you change stuff. Like here, 2020, let's change that to 21. And then you do something else. For example, remove this thing here and this thing. Maybe this here also. Hopefully this is a conflict, we will see. And well, close it. Now when we go here, we have this new change. So that now the good thing here is that you can look at the changes. And I already told you, this is the staging area is a good thing, especially in this setting, because what I can do now is I can have inline the diff what changed. And for example, for the copy here, I see, okay, I changed this and I changed this. When you don't have this, what usually happens is, especially if you're like me, I do tons of changes and I don't commit. Yeah, that's bad. Commit often. That's a good idea, but I don't do it. And so I end up with a lot of changes that are unrelated to each other and shouldn't end up in the same commit. But because I'm lazy, I think then, come on. I write maybe a commit message like that belongs to the last change, or even better, I write minor changes. Minor changes is a favorite. And there we are. And this makes the documentation part of using a version control management obsolete. Yeah? And so it's much better. And that's now the good thing about the staging. What you can do now is you can selectively add the parts of the changes to the next commit. Like here, I add this one. And as you can see now, I look now, this single change now is added to the staging area. The other changes are still unstaged. And now what I can do, I do the commit just with this single change, adopt copyright here. And there we are. And there we see now, okay, we have one unpushed revision here locally and still those changes. So some other benefit is I can easily add stage and unstage files. Like for example here now it's only this change is left, so I can stage it just with a single key press. And then later on, when I think, oh no, I don't want to change it to submit it now, I can unstage it just by a press without remembering awkward commands. Now let's stage it and commit this. Clean up. By the way, here this plugin educates me to good commit style, because now when I type too much text, right, he will not color it anymore, yeah, because it shouldn't be longer. I think 50 characters or something. So clean up, and you could then with a empty line add some more information, yeah. So like doing stuff, yeah, and then this line is shown as a summary in this one-line log setup, and this is then the additional stuff. If you use GitHub, you also might just reference here as a last line, for example, an issue ticket, yeah, like fixes ticket 63. Yeah, and if there is an issue ticket 63 on GitHub and GitLab, this will be automatically linked to the issue ticket. Yeah? So that's another possibility. Okay, so let's get rid of this commit. Now we have two commits. And well, what we want to do now, I want to push those changes. And of course, because I didn't get the last changes we did, I again get a rejected push, and I pull. Now there is an additional thing, and this is your local changes to the following files would be overwritten by the merge. Please commit your changes or stash them before you merge. So we didn't commit the changes to try it, and there were changes to the same file. So what we need to do is to commit this also here, and I do this from here because it's just for me more convenient. Here you see how the fetch happened. He fetched the stuff. He got all the revisions that are on the server, but he didn't merge it yet because the merge didn't succeed first of all, because of this unstaged file. So edit, committed, minor changes is good. And close again. Let's do the git pull again. Oh, the auto merge worked. That's really bad. Okay, the auto merge worked. So we need to provoke another conflict. I'm sorry for that. So let's edit copy. And what do we do? Let's do a e equals 1. Yeah. Change start index or whatever. Push. Let's go back here. And here the auto merge worked. Yeah, so that's a bad thing. So that's, what was it? It was copy or? Yeah, copy. And let's start here with 4. Let's see if we can merge that. Okay, git pull. Merge conflict in source copy C. Great. Yeah, so automatic merging failed, fixed conflict. So let's look at that now in my fugitive. How does this look like? He has now the source copy in unmerged and unstaged, and he has it in staged. And what we want to do now, and I guess it will not fit in here, we want to merge this. And when we open now, when we do when I do now a diff, and this is what you want to use, a diff tool, you get a scary thing called 3-way merge. And unfortunately, because of the large font, there's not much you see, but we see the important stuff. So what is this? We have the source branch on the right side. So we're merging from a source. In this case, this is remote master to our local branch. This is the version here on the left side. So this is local master. And this file in the middle, that's our working copy. And this is where we want to fix the conflict. Yeah. And what we do now here is, well, we have now a good site. What is the source? What is the destination? And well, we can fix it. Yeah? We can decide what to do, or we can do something entirely different. Yeah, doesn't matter. So remove that and put a 0 there, because they were both wrong. We know that. And G write. With G write, this will be closed and will be staged. So will be automatically added. And now, as you see here, this is staged. And actually, yeah, those are part of the merge. Yeah, so he also merged them. And when we now commit those, you get merge branch master of remote blah. And well, just throw that, and there we are. Yeah. Right. Okay, so this is everything I wanted to show you. So I hope I could motivate why it's really a good idea to use an editor, because, or an integration, a GUI, yeah, either an editor integration or a GUI front end to Git. You don't have to remember all those commands. You have a good diff. Oh, one thing I didn't do. Look at the log. Jesus Christ. Here. Let's close this. Here is, for example, how the log looks like. You have here the one-line thing, and then you can quickly cycle through the different things and have the diff here. I can look at the changes. So it's quite useful. If you use Vim or another editor or a front end, that really doesn't matter. But I think especially for larger projects, it's a good idea to not do this on the command line. You can do it, but it really is helpful to have GUI support for that. So, okay, so now let's start, or let's finish with the rest of the slides. We already are quite late. I hope this is okay for you. So for the staging area, the general advice is commit often. How often, that's up to you. In general, I would say changes should belong to the same issue ticket or the same topic. Yeah. So if the changes are explained by a single description, then it's fine. Let's say, for example, you change the year of the copyright in all the files. Well, then this can be one commit because it's sufficient to write change copyright year. Yeah, and this explains what you did. And so this can end up in the same commit. Yeah? So it's really up to you how you do that and how often you commit. In general, people do not commit often enough. Yeah? So this is me, for example. Then do detailed commit messages. Yeah? To that this documentation feature is useful, you really need to care that you explain what you did. Yeah? And more on meaningful commits on the next slide. This staging area might seem strange if you switch, let's say, from Subversion. And of course, you can skip the staging by using this -A switch, but I really recommend to use it because you really learn to appreciate, especially if you wildly change things without committing and then end up with a state that doesn't fit into one commit. When you have a lot of unrelated changes that don't belong to the same commit, then this staging area is very useful. It allows you to review your changes and to really plan and decide which changes should end up in which commit. Some best practices for good commit messages. Well, at the least, the commit message should explain what and why you did, not how you did it, because how you did it, well, that you can just look up yourself. It's in the diff, yeah, because the diff is part of the commit. The format is you should have a summary in the first line, capitalized, short, 15 characters or less, and then a more detailed explanatory text if necessary. This if necessary is important. So what and why, if your summary describes sufficiently the what and why, then you don't need this. But if you did some more complicated change, then you might want to explain what you did. One additional remark, when you use an issue tracker, and an issue tracker is not part of Git, but all software as a service platforms like GitHub or GitLab have an integrated issue tracker, you might, as a documentation, add references to those issue tickets. Yeah, and that's also fine, yeah, because that's also sufficient. You don't need to repeat yourself when you already explained what you did in the issue ticket. Then it's sufficient here to just reference it from the commit message. The summary from option by using a second -m option. Then the first -m is the subject, so the summary, and the second -m is then the description. So here is an example for more or less good commit messages. And what they say is you should use imperative like rework, add tests, and so on. And this is an additional example on a commit message. Yeah, so really try to get in the position of the person who didn't do the change, and would it be possible for an outside person to understand what you did? Yeah. For reviewing changes, well, I showed you the integrated diff in Git. Of course, you can also do this on the command line. So Git also has diff functionality built in. You can use an external diff tool. How to set this up is in the slide set. But I really recommend to do this in an editor or GUI. Yeah? So it's tedious to do it on the command line. So I really recommend, especially if you have a conflict, use a diff tool. Yeah? One additional topic that is important is the decision which files need to be tracked. And there the general recommendation is only put source files under revision control. So no intermediate build products, no hidden system files, no binaries, libraries. Of course, there can be exceptions to this rule, but this is generally valid. Git gives you some help to do this, to enforce that. You can specify files or patterns of files that you want to ignore. And ignore means that they don't appear in untracked or other categories. And you can have this Git in your file. This list of patterns. Here are some examples. Usually you have one Git in the root of the repository, but it's possible also to add them in multiple directories, and then they incrementally add those rules and build a final rule set. A good service of GitHub is when you create your repository on GitHub, it will offer to you to add a Git in your file. One thing, of course, this Git in your file is only useful if you commit it, if you add it. And GitHub maintains a good list of examples for different languages, so you might pick up one there, and then you can go from there and refine it to your needs if you have more complicated requirements. One thing I didn't show in the demo is branching, just lack of time. But I still want to introduce it. We were discussing if this is an advanced feature or a basic feature. Of course, you can get away just doing everything on the master branch. But it's not recommended. And the reason is, one advantage of using a version control system is it gives you some more relaxed, some safety and control about changes. Because when you do changes, you always know you can go back to a safe state. And branches make this relaxed attitude against changes even more relaxed. Because when you do changes initially in a branch and you really mess up, you can just erase the branch. You can delete the branch and it's gone. On the master branch, things are more difficult. And the recommendation, and those are all conventions. So what workflow you use, that's really up to you. But this is a workflow, it's called feature branches, that have proven for a lot of things to be of advantage. So first of all, use branching. Also myself, I don't use it enough. I usually don't care about the documentation feature. And this means I don't care if the history is meaningless. But if you care, you should use branching and keep the history clean and sane. And one common use case is that you, for a change or for a thing you want to do the things always in a branch from the master. To create a branch, you'd use git checkout -b hotfix. That's actually a combined command, but for this purpose, this is what you want to do. This will create the branch hotfix and check it out. So change your branch to this new branch. Then you modify files and commit changes, and you can do this multiple times. Let's say you could create a branch for porting it to a new architecture or a new compiler, and then you name the branch accordingly. And then when you are finished, you will check out again the master, and then you will merge the changes from hotfix into master by git merge hotfix. And finally, when you're done, you can delete the branch. So because you don't need it anymore to keep things clean. Of course, before you merge it in the master, you want to test it and validate it, that it's or review it. So the recommendation is, and this is to give you security. Yeah? So to give you some baseline where you know I have this baseline, I can mess up really bad. I always can get back to this baseline. And so the recommendation is your master should always be a working and tested state. So never mess with your master. Master should always work. Just a remark, of course, for larger projects, this may not be sufficient. Yeah? So this will work, but for really large projects, you may want to introduce maybe a second long-running branch, develop, for example, branch the feature branches of this development branch, and then just validate. If you have one guy who integrates the stuff, he integrates it then again to the development branch, tests it, validates it, and only then it gets from time to time merged back into the master branch. But as I said, there are different models and workflows, and this is the topics of another talk. But I recommend still, even if you're a beginner, use the branching feature. It gives you really a more relaxed and a safer way to do things, and it's generally recommended. And in Git, it's also really easy to do. Yeah, okay. So we already covered that, so we can skip this now. One last thing. Well, here again, I want to say you really want to do this in an editor or GUI, not on the command line. Of course, when you have one change, that's fine. But when you have a huge file with 10 changes, probability is high that you mess up something. Yeah, and so you really want to do this in a merge tool. So finally, some words on communication protocols and authentication. In general, the repositories are standalone, and from time to time, you already have seen this, you need to sync information between the different instances of the repository. And Git supports 4 protocols. The most common protocols is HTTP and Secure Shell. And for Git, when you're logged in, usually he will offer you, or he will recommend to you Secure Shell, but you may also authenticate over HTTP. Yeah, just for you. We don't go into this in depth. The Secure Shell authentication is usually done with Secure Shell keys. Well, with all the complexities, we had a talk on that comes with Secure Shell key authentication. Yeah, but just that you know, but still, this is the most widespread way in exchanging information between repositories. Some remarks on GUIs. There are a lot of options. Please look at the Git website for other options. There are now only here some examples I found. I used only of those options SourceTree. SourceTree is from Atlassian. This is, in my opinion, a very good GUI. Still nowadays, I prefer to use the Vim. Vim is my main editor, and so for me, it's more convenient to not leave it for the Git interaction. And so I use this Fugitive plugin, which is, I think, really a great Git integration. Yeah, but of course, you can also use SourceTree. There's now a new option, GitHub Desktop, unfortunately only available for Windows and Mac. And people say that it's also very good. So you might try that. If you're an Emacs guy, there is Magit. Yeah, Georg said it's complicated, but I don't know. If it's complicated, it fits with Emacs. If you're on Linux, if you are on Linux and want an editor with an integrated Git support, you might want to have a look at Visual Studio Code. And Visual Studio Code comes with I didn't try it, but people say powerful built-in Git integration. So maybe you give that a try. Finally, on the server side, well, Git is commonly used as a software as a service offering. And there are 2 main players. There is GitHub, which is now owned by Microsoft. And there is GitLab. GitLab is an open core company. And GitLab can also be, you can also host, and this is a common case, host GitLab yourself. So this is common as a self-hosted option. Other simpler options is Gitolite. That's some really lightweight, without web interface, just a central server with a fine-grained access control based on secure shell keys. This is, for example, something I use privately, where when I quickly want to add repositories, I don't want to do this on GitHub. I have a Gitolite server. And if you want some web interface and are kind of the hacker guy, there is ZJIT. That's a minimalistic web interface, and this can be then easily combined with Gitolite if you want something more special. Now, the outlook. There are a lot of things in this talk we didn't cover. Yeah? So, for example, advanced workflows and development strategies, commands like git stash, which is very useful, git rebase, git submodules, and a lot of other things. Yeah. Well, the talk was long enough, and so I hope you understand. We may add an advanced talk, which is then targeted on software engineering, because a lot of those things are related to questions on how you do your software engineering, software development engineering strategy. For self-study, there are two pointers I want to give you. First is the online book you get on the Git website. This is really for self-study and reading it. Atlassian also has some a collection of good Git tutorials, a bit more compact than the book. So this is more a complete reference. And down here you have more standard use cases. So you want to maybe give a try to both of them. And that's it from my side.